Okay, so what we're going to be talking about today is a 45, 45, 90 triangle and talking about how these sides always look. So we're going to be talking about two special types of triangles. A 45, 45, 90 is what we're talking about today, which is basically a special kind of right triangle, which I've drawn up here for you, where you have a 90-degree angle, so right triangle, but both of the two small angles are the same measurement. They're both 45 degrees. So in this, you're going to think kind of like scale model type deal. So what you're thinking of here is you are trying to figure out what the legs are supposed to be and versus what they are now. So this is kind of the base model. You have 45 degrees and 45 degrees, and then you have two legs that are both 1, okay, and the hypotenuse is always the square root of 2, okay. So this is kind of like the base model of what the triangle is supposed to look like. Now what's going to happen here is they're going to be adjusting these legs, and we're going to compare it to the original, or we're going to compare it to the hypotenuse of the original and find what it's actually supposed to be. Okay, so whenever we're looking at these triangles, we're trying to find what the value of x is. Okay, I'm going to compare this to my original 45, 45, 90, which is supposed to say both legs are 1 and the hypotenuse is square root of 2. Okay, so right now they're asking us to find x. Okay, so they're asking us to find x, which is supposed to be a square root of 2. Okay, but it's something else now because all the other sides are bigger. Okay, so right now we're going to use what we do know. Okay, and we're going to look at 10. Okay, that side that they gave us. Okay, that's supposed to be a 1 in the original triangle. So in order for them to get from 1 to 10, okay, they had to multiply by a factor to get there. Okay, in this case, they had to multiply by 10. They had to do times 10 from the original triangle to get that new leg. Okay, now in order for this to be like a scale model, everything has to change at the same rate. So that means they also had to multiply this leg by 10 and also this hypotenuse by 10. So if I know that the hypotenuse is supposed to be square root of 2, okay, in the original model right here, this is the square root of 2. Everything's getting multiplied by 10. Okay, I just have to multiply 10 times the square root of 2. Now, the good thing about this is they want an exact answer using radicals. So that means that they want you to leave it as square root of 2 times 10 or 10 square root of 2. You don't have to actually figure out what that is as a decimal. Okay, you just have to figure out what that is with a square root symbol. Okay, now you can also think of this as a proportion. Okay, so another way that you can write this question, okay, original leg was 1 and it became 10. Okay, original hypotenuse was square root of 2, and it was x. Okay, and then if you're solving using a proportion, you cross multiply these two and these two. Okay, so 1 times x is x, 10 times the square root of 2 is 10 square root of 2. Okay, so you can definitely use algebra and cross multiply to get this, or you can just look at what were we supposed to have versus what we have now. Okay, so let's look at a couple of examples using this triangle. Okay, so 45, 45, 90, we're trying to find x, so I'm going to redraw the original several times until you guys get it. I would definitely have this original triangle copied down somewhere so that you can refer back to that on your homework. Okay, so both legs are supposed to be 1, hypotenuse is supposed to be square root of 2. We're trying to find x. Okay, so we're trying to find this right here. Okay, now x is a leg. Okay, leg is supposed to be 1. Okay, what we know right now is the hypotenuse of 20. It's supposed to be square root of 2. Okay, so again, if you want to use cross multiplying, that's probably the easiest thing to do here. Okay, my x is supposed to be a 1. Okay, my 20 is supposed to be a square root of 2. Okay, and there's several ways you can write this proportion to make it equal. Okay, but make sure that the comparisons match up. Okay, so if I'm looking at x times square root of 2, that would be square root of 2x. If I'm looking at 1 times 20, that would just be 20, okay? Now, the sucky thing about this one, okay, and I'll say it's a sucky thing just because you have to remember some algebra, is you are dividing by the square root of 2, okay? Now, from Algebra 1, at the very end of Algebra 1, you learned how to rationalize a denominator, which means you cannot have a square root in the denominator. Okay, so in order to get rid of a square root, you multiply by itself on top and bottom. So we're multiplying by square root of 2 because that's what this says right here. When I do that and I multiply straight across, that becomes 20 square root of 2. And on the bottom, square root of 2 times square root of 2 is the square root of 4, which is just 2. Okay, at this point, you have to reduce this. Okay, 20 over 2 reduces to 10. So this becomes 10 square root of 2. Any questions so far? Okay. All right, so now we're going to be finding the value of x and y. Okay, so x and y this time. So our original triangle was supposed to be, again, 45, 45, 90. So 1, 1, square root of 2. Okay, and we are comparing that to this 5, x, and y. Okay, so we always have to use the side that we do know, okay, which in this case is the 5, okay, and finding x first because that's the first thing it asks for. So when I'm looking at x, it's supposed to be a 1, okay, using what I do know, okay, 5 also supposed to be a 1, okay, so we're going to write a proportion that says that, okay, x is supposed to be 1, okay, 5 is supposed to be 1, okay. Now, this one should be pretty easy to figure out because if the legs were supposed to be the same before, okay, they should be the same now, okay? So if I cross multiply, that's going to give me x equals 5, which makes sense because in the original triangle, I had 2 legs that were the same of 1. So now both of these legs have to be the same of 5, okay? Then we're going to write a second proportion, okay, using our same things, okay, the side that we know and the side that we're trying to find. So now, find a different color here. Okay, we're looking at square root of 2 and comparing it to y. Okay, so square root of 2 compared to y. Okay, use the side that we know. 1 is supposed to be 5. Okay, so we're going to cross multiply here, these two and these two. Okay, y times 1 is just y. Okay, square root of 2 times 5 is 5 square root of 2. Okay, so there's your x and there's your y. And your triangle is solved. Okay. Any questions there? Okay, so on number 4, same thing. This is the last one we're doing. I know you guys don't have the notes. I am going to upload these for you guys onto Canvas whenever we're done. So there is pages to this that you don't have necessarily, but I will upload those for you. So looking at this last one here on this page, okay, I've got 45, 45, 90. Okay, compare that to the original triangle, 1, 1, square root of 2. Okay, so the side that I know is 30. That's one of the legs. Okay, which is supposed to be a 1. I'm trying to figure out what y is. Okay, so I'm going to compare that to square root of 2. Okay, so 30 is supposed to be 1. Y is supposed to compare to square root of 2. Okay, so now cross multiply there. Okay, 30 times the square root of 2. 1 times y, that's going to be y equals 30 square root of 2. Okay. Any questions as of right now? If you guys have a question, just unmute yourself. Okay. Okay, so this one we actually already did. It was the same as number 2. Okay, so fill in blank for the special triangle. Okay, so on this one you're finding the measure of angle B. Okay, so the main thing here is just understanding the angles of the triangle and what's happening here. Okay, so right here is angle B. Okay, so right now that's a 45. This is a 90. The only thing that this could be right here is 45 degrees. If you're not sure how to get that, you can go back to what we've been doing. Subtract the 2 angles that you do know, this 90 and this 45 degrees. Okay, that's going to leave you with 45. Okay, so selecting my options here. Okay, that's going to be 45 degrees. Okay, now knowing what I know about a special triangle, I can also find what the sides are. Okay, if this is 45 degrees, yeah. Can you go back to the previous slide for a minute? Yes, sorry. I forget you guys don't have a paper for multiple choice. All good, Autumn? Yeah, I'm good. Okay. Okay, so knowing what we know about a special triangle, we can also fill in what the sides are supposed to be. Okay, so in this triangle, you're trying to figure out what side A is. Okay, so side A is a leg. Okay, so compare it to this leg right here. These should be the same. Okay, so if this one is 1, this one should be the same as that. Okay, so it should also be 1. Okay, they're not asking us what C is, but if they did ask us what C is, it is the square root of 2. Okay, and where this comes from, in case you guys are wondering, I didn't just pull this out of a hat. Okay, go back to Pythagorean theorem and use the legs being 1. 1 squared plus 1 squared to find the hypotenuse squared. That's where that square root of 2 comes from, because you have this. Okay, this is how you would get that hypotenuse of square root of 2. So this is where this actually originates. Okay, so I didn't just make up 1 square root of 2. That does have a meaning for that. Okay. All right, any other questions as of right now? Okay, so on this one, it's asking you what is the value of x. Okay, so what is the value of x? You're trying to figure out what the hypotenuse is. Okay, so this one right here. Okay, compare that to our original triangle. Okay, 1 square root of 2 for 45, 45, 90. Okay, my hypotenuse was supposed to be square root of 2. I have a leg of 4 that I can compare to the leg of 1. Okay, so 4 compares to 1. X compares to square root of 2. Okay. Now you can write that in any order. You can also write 1 over 4 equals square root of 2 over x. Okay. So cross multiply here. These two and these two. Okay. 4 times the square root of 2 is 4 square root of 2. 1 times x is x. There's nothing left for me to solve there. Okay. So x is equal to 4 square root of 2. Now, I do want to do one more about the rationalized ones, just to make sure that we're on the same page of how that works. So I am going to skip a couple things here, because normally if you guys are here, I'd say you do these, but you don't have paper to look off of, so I'm not going to have you do a bunch of them on your own. So I'm going to skip over to 11, which is another example of that rationalizing the denominator where you have to get rid of the square root. Okay, so if I look at my triangle, okay, compare that to my original 45, 45, 90. Okay, I have a hypotenuse of 22 that compares to the hypotenuse of square root of 2, and I'm trying to figure out what x is, okay, which compares to the leg of 1. Okay, so 22 hypotenuse goes with hypotenuse, square root of 2. X is a leg, goes with the original leg of 1. Okay, so whenever you're writing these, make sure hypotenuse is matched up and legs are matched up. Okay, now if I cross multiply these two and these two, 22 times 1 is 22. Okay, square root of 2 times x is x square root of 2. Now, here's the rationalizing part that most people have a little bit of trouble with. Okay, when I divide by square root of 2 on both sides, I cannot leave this as 22 over the square root of 2. You're not allowed to have a square root in the denominator. Okay, so to get rid of a square root, I'm going to multiply by whatever that square root says, square root of 2. Okay, and I'm going kind of backwards here because I wrote it on the wrong side. Okay, but if I multiply across, okay, square root of 2 times 22, that's 22 square root of 2. Square root of 2 times square root of 2, multiply the numbers underneath. So 2 times 2 is 4. Square root of 4 is 2. And then you reduce. And it's the same thing every time. It's the same steps every time. Okay, you're going to multiply straight across. You're going to multiply to rationalize the denominator, and then something is going to cancel. Okay, so 22 over 2, that's going to reduce down to 11. I still have square root of 2 right there, so I can reduce that. Okay, so that becomes 11 square root of 2. You guys have any questions as of right now? Okay. So sometimes these fractions do get a little more complicated, such as this one. Okay, on this one, the leg they're telling you is 3 square root of 13. Okay, so when I say this gets a little more complicated, all that means is you have a little more math to do. Okay, so my original triangle looks like this. And you'll notice every time I draw this triangle out, I draw it the way that it looks so I can compare it easily. Wherever the right angle is where I put the right angle when I redraw my triangle. Okay, so I've got 1 square root of 2. Okay, right now they're giving me a leg, which was supposed to be 1. I'm trying to find the hypotenuse, which is supposed to be square root of 2. Okay, so let's compare leg to leg. So 3 square root of 13 over 1, and hypotenuse to hypotenuse. So y over square root of 2. Okay, now whenever you multiply these, and you multiply these two things and these two things, 1 times y is y. Okay, 3 square root of 13 times the square root of 2. You have to remember algebra here. You only multiply square root numbers that are underneath the square root numbers. So the 3 is going to stay. Okay, under the square root is whatever 13 times 2 is, which in this case is 26. Okay, so you don't multiply the 2 times both of these, only the square root of 13. Okay, you don't have to do anything else to simplify that. So y is 3 square root of 26. Okay. So a couple of just basic algebra things that you need to remember there. Okay. Any questions about that? Now, they will give you like an application type problem where they use a bridge. Okay, so it says the bridge has a 45, 45, 90 right triangle supports. If the hypotenuse of each support is 24 feet, find the length of the leg. So basically what's happening here is here's the supports. Okay, I'm just going to draw it a little bigger. It looks like this. Okay, and the hypotenuse is 24 feet. You're trying to figure out what's the length of the legs. Okay, so if I compare that to an original 45, 45, 90, 1, 1, square root of 2, okay, now you can set up your proportion and solve that. Okay, so if I set up my proportion, okay, that's going to say that 24 and square root of 2, I can compare those. And x and 1, I can also compare those. Okay, so cross multiply here and here. Okay, so 24 times 1 is 24. X times the square root of 2 is x square root of 2. Okay, this is another one you're going to have to rationalize. Okay, so divide by square root of 2. Rationalize the denominator, so I can't have a square root in the bottom, so multiply top and bottom by square root of 2. Okay, go straight across. 24 times square root of 2 is 24 square root of 2. Square root of 2 times square root of 2 is square root of 4. Square root of 4 is 2. Finish this by simplifying. If you type that in like that on Math Excel, it's going to tell you it's right, but it's not simplified. So 24 over 2 is 12. I still have square root of 2, and that's what x equals. Okay, now it says the length of the first leg is, and the length of the second leg is. Well, they're the same. Okay, in a 45, 45, 90, the legs are the same, so they should both be the same answer. Okay. And that's all we have for the notes. Okay, are there any questions as of right now?